Today we will be looking at key features of quadratic functions and their forms. So first, there's a whole picture here. We're going to identify the key features, but let's talk about what they are first. The vertex is the point where the graph changes direction. It represents the maximum or minimum of the graph, so it's the lowest or highest point of the graph. The axis of symmetry is the vertical line through the vertex that splits the line symmetrically. So if we go back to our picture, the vertex in this picture, where it changes direction, would be down here at -1, -4. And then the axis of symmetry would be a vertical line drawn through that, so it's the same on both sides. So that equation is always in the formula x equals, and it's whatever the x value was of the vertex. So x equals -1. The x-intercepts are where the graph crosses the x-axis, but they're also considered the solutions. So it can have two x-intercepts, one x-intercept, or no x-intercept, right? It's when the function is equal to 0. So in our picture here, we do see that it crosses the x-axis twice. It crosses it at -3, 0, and it crosses it at 1, 0. The y-intercept is where the graph crosses the y-axis. If it's a word problem, it's often what they refer to as the starting position, like they threw it from a height of. So in our picture here, we have a y-intercept, or it crosses the y-axis, and that's 0, -3. Decreasing and increasing intervals are the side of the graph that's either decreasing from left to right or increasing from left to right. The axis of symmetry will always split it. So what I would do here is, if I was looking at my graph from left to right, first I was going down, right? To draw my graph, I had to draw it down. So first was a decreasing interval. It started decreasing all the way at -infinity and kept decreasing until we hit x was -1. But at -1, it's actually staying still. So we're not going to include -1. We're going to put a parenthesis there instead of the square bracket there. Now remember, this is interval notation. These are ordered pairs. It's going to get confusing because they will look the same. So you have to use your context clues as to what they're referring to. The increasing interval then would be if I started here and started going up from left to right. That would be my increasing interval. So it was staying still at -1, but it started to increase right after it, and it kept increasing forever all the way to infinity. Domain would be all possible inputs. We already said for quadratics, they're going to be all real numbers, or -infinity to +infinity. And then the range is the outputs. So we did talk about that when we talked about the transformations of our function. Right here, our domain is all real, -infinity to +infinity. And my range, because it's everything above a certain value, so we're going to go all the way up to infinity, and we're going to have a bottom out. The very bottom was when y was -4. So it goes from -4 on up, so -4 is where it started, and went all the way up to +infinity. The last thing we're going to talk about is end behavior, and that's how the ends of the graphs react as x goes to either positive or -infinity. So really, what happens on the left side of the graph, what happens on the right side of the graph. So it's often written, let's make it a little bigger here, well, really a little smaller for you. So f of x does what as x goes to the left, to -infinity, and f of x, the graph, does what as x goes to +infinity, or just infinity. So on the left side of my axis of symmetry, right, the left side, we see that the arrows would be going up. So that would be going to +infinity. And on the right side of my axis of symmetry, it's also going up. So that's also to +infinity. So our end behavior should always match for a quadratic. Right? If the arrows are pointing up, it's going to be positive. If the arrows are pointing down, it's going to be both negative. That will change once we get to other polynomials. Then it might be different signs, but for now, for quadratics, same sign for both. So we just did this, but now let's do it for a fresh graph. The domain here, right? All real numbers, negative infinity to infinity. The range, I have a high point, so the highest value of y is 9, and everything else was below it, so negative infinity to 9. My x-intercepts we crossed at, looks like these go by ones, so negative 1, 0, and 5, 0. The y-intercept, where it crosses the y-axis, was 0, 5. My axis of symmetry, right, through the vertex point would be x equals positive 2. And that means my vertex has an x value of 2 and a y value of 9. The max or min, so we have to do two things. We have to say if it was the max or the min. So this was the highest point in my graph, so that's the max. And what was the value? What was the highest number that we reached? It was 9. So the max value is 9. It should match with our range. We said the highest number it went to was 9. My increasing and decreasing intervals. So first, I was going up, then I was going down. So increasing was everything up to x is 2. So negative infinity to 2. And then it started to decrease, going 2 all the way to infinity. And my end behavior, write out my setup first. So both sides of this graph are going down, so both are going to negative infinity. So there's one here for you to try. You can pause. The answers are posted on Google Classroom in the blank notes at the very end. So some NJGPA practice. So the function here is graphed. We want to classify classify each given interval to indicate whether the function is increasing or decreasing on that interval. So if we started everything to the left of 0, right? X is less than 0. So what's happening here? From left to right, it's going up. So that's increasing. From 0 to 2. So 0 to 2. I'm still going up on the graph. So that's still increasing. From 2 to 4. So now left to right, I'm going down. So that would be decreasing. And from 4 onward, X is bigger than 4. That's still decreasing. For part B, we now want to label each given interval if f of x is less than 0 or f of x is greater than 0. What that means is if I took the x-axis, is my function, is my line happening above or below that line? Right? Everything up here is f of x is greater than 0. Everything down here is f of x is less than 0. So for x is less than 0, so everything here, that's all below the graph, right? So that's less than 0. Between 0 and 2, right? Between these two parts, my function is above the line. So that's greater than. Between 2 and 4. So again, that's above this line, that's greater than. And for everything x bigger than 4, so everything over here, that's now below the line, that was less than. So there are 3 different forms for a quadratic equation, and each one can help us identify different key features. So vertex form can help us find the vertex. Right? The vertex would be h comma k, the opposite sign of what's inside, the same side of what's outside. The vertex form allows us to find the max or min value. So if you're doing a word problem and they want to know what form would be best to find the highest something reached or the lowest something reached, that would be vertex form because that allows us to get the vertex, allows us to get the min or max value. Intercept form gives us the x-intercepts. And whatever numbers are in the parentheses, it looks like it's factored. So this would be p comma 0 and q comma 0. So this is best for when did something hit the ground? When were things equal to 0, right? When was the y value equal to 0? And then standard form will tell us the y-intercept, because remember the y-intercept is when x is 0. So if x is 0, this is gone, and if x is 0, this is gone, so all we're left with is c. So the y-intercept would be 0, comma, c. So this is best if we wanted to know the starting position for something. So if we look at example 2, we're going to identify which form each quadratic is in and identify its key feature. So this first one is in vertex form because it has one set of parentheses being squared. So the vertex form gives us the vertex, which in this case would be opposite of -5, +5, comma 7. This is standard form, and standard form will give us the y-intercept. So the y-intercept is just whatever this last number is. So it's going to be 0, comma, -6. And this last one is in intercept form. And it gives us the the x-intercepts. So +4, 0 and +8, 0. So here's one for you to try. You can pause. The answers are on the blank notes on Google Classroom. In example 3, we want to write the equation of the quadratic based on the graph in the given form. So this one asks for intercept form. So we have intercepts at -2, 0 and at 4, 0, which means the parentheses are going to be x plus 2 and x minus 4. But we do have to account for that a out front. So the way we do that is if we take one point and the next one, it's always going to go over by 1, but whatever it goes up or down by is a. So this is actually going down by 1. So my a is -1. So this would be my equation of this graph in intercept form. -1 times x plus 2 times x minus 4. So for B, this asks for vertex form. So in vertex form, I'm going to find my vertex, which in this case is -3, comma, -5. So that means in the parentheses, it's x plus 3 squared, and outside is -5. And again, we're going to check our a. So it looks like the next point would be there, up 1 over 1. So a is just 1. So I don't have to write the 1 there, but I can if I want. And that's my equation in vertex form. My last one, another intercept form. It's a little blurry up here, but this says 1, comma 0. Look, it's so blurry I can't tell. 1, comma 0 and 5, comma 0 are our two intercepts. So that means it's going to give us x minus 1 and x minus 5. But again, we need that a value. So here, going over 1, it actually went up by 2. So the a value in this case is 2. Here's 2 for you to try. You can pause. The answers are posted in our Google Classroom in the the blank notes. So what if we wanted to convert those two equations into standard form? So I'm going to take one of them. Oh, I'm going to take the previous ones that we did. So example 3, I have -1 times x plus 2 times x minus 4. So -1 times x, I already forgot what it was, plus 2 times x minus 4. So if I wanted to get this into standard form, I would worry about multiplying these two by each other first. I'm going to save the -1 for last. So when I multiply these two, right, we have the FOIL method, first, outer, inner, last, or think of it as the distributive property. So x times x is x squared. X times -4 is -4x. Then we do the inner one. 2 times x is 2x. 2 times negative 4 is negative 8. I can combine some like terms in here. So negative 4x plus 2x is negative 2x minus 8. And then we have to distribute the negative 1 to everything. So this would be negative 1x squared plus 2x plus 8. So that would be the standard form of example 3a. If I wanted to look at example 3b, the one that was originally written in vertex form, right, that was y equals x plus 3 squared minus 5. So this x plus 3 squared, you are not allowed to distribute the power. It doesn't work that way. What we can do is say because it was squared, it was x plus 3 times x plus 3. So for this part, we're going to do what we just did over here, right? Multiply x by x by 3. Then we're going to multiply 3 by x and 3 by 3. And I'm just going to bring down the minus 5 because it's not times negative 5, it's just minus 5. So when I combine like terms here, 3x and 3x made 6x, and then 9 and minus 5 was plus 4. So you can switch between the forms. If you need it in standard form, you can certainly start in one of the other forms and then convert it. That is the first day of quadratics.